hello grade 9s, and this is not a lesson, it's just more of an explanation because a bunch of you have asked me about the decibel scale and how to do the questions, and I know it was in the homework, and I did help many of you with it, but I'm still getting questions on it. And alright, so let me explain it. Okay, so when we were in class still, and we were doing, we actually did some of this together. I tested your hearing. Remember those high pitches and everything? We talked about that and we went through the hearing test. And yeah, in fact, I showed you this, gave you this handout, and this is actually when we were in class together still, before the break, okay, before Mr. Brash, but it's been a long time, okay, since that time. So let me explain it again. And the way I'm going to explain this, okay, like here there's a chart, okay? So what does it mean, okay, 0 decibels? Does that mean 0 sound? Well, no, not really. So I know that there are notes here, but I'm not just going to read these notes to you because that's a boring way to explain something. What I'm going to do is I'm just in the margin here. I'm just going to explain something to you, okay? Decibel scales increases by powers of 10. So let me explain. Okay, sound. Okay, actually I don't want to write that down. Sound is measured in a unit called watts per square meter. That's a measure of power. Okay, so I'm going to write it like this, watts per meter squared. Okay, and that's a measure of the power in a sound wave spread out over an area, let's say like the area of your eardrum. Okay, so sound is measured in watts per square meter. The quietest sound that you can hear, we call this the threshold of human hearing. Okay, and I'm going to underline this, human hearing. There are animals that can hear quieter sounds than us, but the threshold of human hearing is 10 to the negative 12 watts per square meter. Now that is actually a really, really, really quiet sound. Okay, so that is the quietest you can hear. That is the definition of 0 decibels. 0 decibels corresponds to a power 10 to the minus 12 watts per square meter. So what we do, because we're human, we define the quietest sound that anyone can hear as 0 decibels. Okay, so we start the scale from there. Now, if you had a negative number like negative 10 decibels, well, maybe a dog could hear an even quieter sound, 10 to the negative 13, let's say, watts per square meter. That's even softer. So that would be even quieter than this number, and that would be actually negative 10 decibels. Okay. Anyway, from there, okay, the decibel scales go up by powers of 10. Okay, so 10 decibels. This is here. Well, actually, it makes more sense over here. This, I didn't write that right. 10 to the negative 11 watts per square meter. This is 10 times louder. Okay, so if I multiply 10 to the negative 12 by 10, I get 10 to the negative 11. And that is 10 decibels. Now, 20 decibels would be 10 to the negative to the power of negative 10 watts per square meter. And again, that's 10 times louder, 10 times louder, pardon me, than the previous sound. Okay, so now if you go to 30 decibels, that's 10 to the negative 9 watts per square meter. Okay, and again, that's 10 times louder, right? 40 decibels would be 10 to the negative 8 watts per square meter. Okay, now you can see the pattern, right? 0 starts with 10 to the negative 12, and then you go up by powers of 10. Okay, so if I keep going, when you get to 150 decibels, well here, let me go 40, here, let me just fill in the chart a little bit. 50 decibels will be 10 to the negative 7 watts per square meter. 60 decibels will be 10 to the negative 6 watts per square meter. Okay, and now I'm going to continue from there, and I'm just going to skip to, let's say, 150 decibels. 150 decibels would be 10 to the power of 3 watts per square meter. That's actually 1,000 watts per square meter. That would be a deafeningly loud sound. Like this would actually perforate, which means put a hole in your eardrum. Okay, that's how loud that is. It's incredibly loud. But if you think about it, how much louder is it, okay, than 10 to the negative 12? Well, it's 15. It's 15 powers of 10 across the decibel scale. Okay, starting with 10 to the negative 12 watts per meter, going all the way up to 10 to the power of 3 watts per square meter. Okay, so you can see, if you understand exponents and powers of 10, each of these numbers is 10 times bigger than the one before it. So you get questions on the test, like on the multiple choice, like how much louder is 30 decibels? I'm going to circle this. How much louder? Here, actually, I'll write the question down. How much louder is, say, 70 decibels compared to 30 decibels? Okay, well, let's go to 70. 70 would be, and I'm going to write, I didn't write it down, so I'm going to write it down. 70 decibels would be right here on the chart, and that would be 10 to the minus 5 watts per square meter. Okay, and then we continue down here to all the way to 150, so we skip a little section. I'll just put a little maybe highlight line there as we go down here like this. Okay, so look, we skipped a bunch of them. So look, I start at 70. 70 is 10 to the minus 5 watts per square meter. Okay, I really did a terrible job there. Watts per square meter. Now, 30 decibels, 10 to the negative 9. Well, how many powers of 10 are there? Well, I'm going to count. 1, 2, 3, 4 powers of 10. So the answer is 10 to the power of 4 is 4 powers of 10. So the answer to this question is 10 to the power of 4 times louder. So in other words, 70 decibels is 10,000 times louder, okay, than 30 decibels. It's more intense by a factor of 10 to the power of 4. Well, 10 to the power of 4 is 10,000. Okay, so that's the decibel scale. It's really quite simple. Now, some students have been asking me, what's up with this weird formula? All right, this is how we make the decibel scale. Now, I don't want to, look, it's grade 11 math. We don't need the formula, though, to answer any of these questions, so don't have to worry about it. All you need is the chart. Okay, that's it. But let me explain the formula. For those of you who care about this thing called the log in your calculator will tell you how many powers of 10 you have. Okay? So let's say, for example, you typed in 10 to the negative 12 in your calculator and you press the log button. Well, the log button, like if I go log of 10 to the negative 12 in my calculator, it'll tell me that the answer is negative 12. In other words, it tells me how many powers of 10 I have in the number. Okay, so the log of 100 is 2, because 100 is 10 times 10, 2 powers of 10. The log of 1,000 is 3. The log of 1,000,000 would be 6, because it's 6 powers of 10. See, so what the log does is it returns the exponent. It tells you how many powers of 10 you have in a number. Okay, so this, I'm going to circle it. This is the threshold of human hearing, right? So let's say the sound, and this one on top, by the way, is the sound you're actually listening to. So let's say you're listening to a sound. This number here is always 10 to the negative 12. Well, let's say the number, the sound that you're listening to is 10 to the negative 12. So it's right at the threshold. Well, a number divided by itself is 1, okay? But the log of 1 is 0, because 10 to the power of 0 equals 1, okay? And so that's why 0 decibels is 10 to the minus 12. Anyway, you don't need to worry about the equation. I don't want you to worry about it because answering the questions is really straightforward. Okay, so like here, there's some questions at the bottom of this sheet. So here, let's start with this one. How many times louder is 120 decibels? That's 120 compared to 60. Well, to go from 120 to 60, that's 60 decibels more, but every 10 decibels is 10 times louder. So it would be 10 to the 6 times louder. Okay? Now, how many times louder is 10 bell compared to 6 bell? Well, 10 bell, and I mentioned this in the notes above, a decibel means a tenth of a bell, okay? So in other words, 10 bell would be equal to 100 decibels, okay? And 6 bell would equal 60 decibels. So just times it by 10, because deci means 1/10. So how many times louder than that? Therefore, that would be 10 to the power 4 times louder, because it's 40 decibels higher. Okay? Sorry, my writing is terrible. It's 40 decibels higher, which means 4 powers of 10. 10 to the power, I need to rewrite that. It's not 104 times. It is 10 to the power of 4 times louder. Okay, so hopefully that makes sense to you. All right, so that's the decibel scale. So it's pretty simple. Now, if I asked you, okay, the reverse question. So, for example, what if I said, what is the intensity? What is I for a sound that is 50 decibels? Well, all you have to do to answer that question is you start at 10 to the negative 12, and then you go up 5 powers of 10. So negative 12 plus 5 is going to be negative 7. So the answer would be, okay, if you don't like that, you can just go to the chart. Okay, 50 decibels would be 5 powers of 10 higher than 10 to the negative 12. So it's 1, 2, 3, 4, 5. That's 10 to the minus 7 watts per square meter. And so you can just go ahead, use the chart, and write it down like that. That would correspond to 10 to the minus 7 watts per square meter. Okay? So, guys, there's the decibel scale. I hope that clears it up for you, and we'll talk again soon.